Moving on to the calculator portion of this 1998 multiple choice AB test, practice test. It says the graph of the function is shown. Which of the following statements about f is false? Function is continuous at x equals a. Well, that's not true because we see there's a removable discontinuity at x equals 1. There's a hole. The graph is not continuous. We can't sketch this graph without lifting our pen or pencil. So this is a false statement. Right? So that's our answer. Let's just go down our these answer choices as well. Function has a relative maximum at x equals a. Well, relative maximum, it seems kind of strange here, but relative maximum just means that immediately to the left and to the right, we have a point that is lower, and that is true even though it's not connected. We could make an argument that x equals a, that there is a relative maximum. X equals a is in the domain of f. That is true. It is within, it is an x value that exists on this graph. The limit as x approaches a from the right is equal to limit as x approaches a from the left. Yes, the limit does exist because if we follow the graph towards a, the graph is moving us towards the same y value even though the y value doesn't exist. But we see the arrows are pointing in the same direction. Limit as x approaches a exists. That is true as well, because if the one-side limits agree with each other, then we can make a conclusion that the full limit does exist. Okay, 77 says let the function f be defined as 3e to the 2x, and let g be defined as 6x cubed. At what value do the graphs have parallel tangent lines? Okay, so parallel tangent lines occur when the slopes are the same. And slopes are the same, we know that is involved, that is referring to derivatives. So parallel tangents, derivative is related to slope. So if we can find each of their derivatives and set the two derivatives equal to each other, then we can find the location where the two curves will share the same slope value. So to find f prime, the derivative for 3e to the 2x is 3e to the, well, it's e to the u times u prime, so 3e to the 2x times 2, which is 6e to the 2x. And then the derivative for 6x cubed is going to be 18x squared. Okay, we set the two derivatives equal to each other, so we're trying to solve for x. And I'm going to subtract 18x squared from both sides. And I'm just trying to figure out when if I were to graph this function, when is this going to be equal to 0? Because this is not something that we can easily solve. So let's make the calculator, let's graph it and see if we can use that as an approximation. So I'm going to graph 6e to the 2x minus 18x squared, and I'll use the calculator to find the x-intercept. So once you graph it, you can use second trace 0 to help you locate that that approximation, and our answer is going to be negative 0.391. Okay, 78, related rates problem here. We have a radius of a circle is decreasing at a constant rate of 0.1 centimeters per second. So that's dr dt. Dr dt is going to be decreasing, so negative 0.1 centimeters per second. In terms of circumference, what is the rate of change of the area of the circle? So if I want to find the rate of change of the area, I'm looking for dA dt, right? With related rates, everything is in relation to time, so d over dt. So we're trying to find dA dt. So the two the equations that we may have to involve are area of a circle and circumference of a circle. So we have a equals pi r squared. We have c equals 2 pi r. I have to find dA dt, so I'm going to have to find the derivative of this equation. So a becomes dA dt. Pi r squared, we go through power rule, bring down the 2. Pi is just a constant. R, 2 pi r, that's the variable radius. And then because we're finding the derivative of radius with respect to time, we need to also include a dr dt. Now I don't know if I need dc dt, but I'm just going to go ahead and just find it just in case. So c becomes dc dt, 2 pi r becomes 2 pi dr dt. So we're trying to find dA dt, so I'm going to put dA dt and see what I can replace. 2 pi r, we want to represent this in terms of c, so 2 pi r we see is the circumference formula, so we can replace c in for 2 pi r. And then dr dt, that's a given value that we indicated as negative 0.1. So we have c times negative 0.1, and that gives us negative 0.1 c. Area, rate of change of area with respect to time, so square centimeters per second. Okay, 79. We have the graph of the derivative of the functions shown. So these are f prime, g prime, and h prime. Which of the functions have a relative maximum on the open interval? So if we're looking at the derivative graph, just understand that anything above the x-axis represents positive slope of the original graph. Anything below the x-axis represents negative slope of the original graph. Anything on the x-axis will be places on the original graph where there's a slope of 0. So if we want to find a relative max on the f prime graph, relative max of the f of x graph is found on the f prime graph by looking to see where f prime changes from a positive to a negative value. So we're looking at an x-intercept. So we know a relative max on the f of x graph is going to look something like this. Right? That's what a relative max looks like. And relative max is going to be where there's a change from a positive slope, turns to a slope of 0, and then goes to a negative slope. So that's what this point gives us. It has that positive slope behavior, slope 0, and it turns to a negative slope. So that's the only point on this is the only graph that has that behavior. We see these other graphs do not even have an x-intercept. So that just narrows down our answer choice to A, to function f. Okay, for 80, we have the derivative graph, derivative function provided, which is f prime. How many critical value does f have between 0 and 10? So we put this in our calculator, and we count the number of x-intercepts. So this is what the graph looks like. And the critical points is wherever there's a slope of 0. So we see between 0 and 10, there are 3 locations with that behavior. Okay, 81. We have a function provided given as absolute value of x. That's just an absolute value function that looks like this. Which of the following statements is true? Is the function continuous at x equals 0? Yes, it is. No breaks. Is the function differentiable? Okay, so differentiable means it's a smooth curve, and we see that this slope changes from -1 all of a sudden to +1. So there's a sharp turn, sudden change in slope. The function is not differentiable at x equals 0. Is there an absolute minimum? Yes, there is an absolute minimum at 0. There's no point on this graph that's lower than this one. So our answer choice, D, because continuous and absolute minimum. Okay, 82, we have a continuous function. F prime of x equals lowercase f of x, and we're trying to find the definite integral of f of 2x dx. So here's the main rule here is that because f is f prime, that means if I take the antiderivative of f prime, it's going to bring me up to f, and then I can do f of b minus f of a. So little f is same thing as f prime, or uppercase f prime. So we're trying to target, eventually we're trying to work towards this, this setup. But this 2x, we got to make sure we deal with that portion. So we have to go through u substitution. We'll let the u value be the portion inside the parentheses, so we let the u value be 2x. du over dx equals 2. We solve for dx, we get du over 2. We make our substitutions there. So I'm going to substitute the 2x with u, substitute the dx with du over 2. So then we get f of u, du over 2. We can push the 1/2 out in front, and then we have 1/2 integral of f of u du. Okay, the integral of lowercase f becomes uppercase f, but we don't want to use the 1 and 3 just yet from the bounds because this is in terms of x, but We have u here, so let's bring our antiderivative back in terms of the original variable 2x. Now we can work in our upper and lower bounds. So upper bound 3 gets plugged in for x. We get 1/2 uppercase f of 6 minus 1/2 uppercase f of 2, and 1/2 f of 6 minus 1/2 f of 2. There's no other information for us to plug anything in, and this actually matches our answer choice E, so that's our answer.